Hi everyone, my name is Jessica and I work at Materialize. I've actually worked at Materialize for a few years now. So I joined as an early engineer in 2019. I was on the engineering team for 2 years. I was our strategic initiatives lead more recently, which means that I talked to you all about technical partnerships if I've reached out to you before. And I'm currently the PM for our cloud product. So I'm trying out every job that I can, apparently. But today I'm going to talk to you about my favorite project and partnership, which is connecting Materialize with dbt. So today I'm really excited to talk to you all about Materialize+dbt and streaming for the modern data stack. So it's the modern data stack's world, and we just live in it. I know I feel this way. I don't know if anyone else feels this way. Every time I open Twitter or look at a blog post, I see another think piece about what the modern data stack is and how it's revolutionizing tech. And if you looked at Twitter today, you saw that Hex apparently created the shoe of the modern data stack. And it's kind of interesting because I did not know what the modern data stack was until like a month ago. And I work in software, so I wanted to start with some definitions for those of you who might have been in the same boat as me. So a data stack is just a collection of all of your data tools. So this is your ingest tools, your transformation tools, your reverse ETL tools, your BI tools, really anything. There's probably 12 categories that I've missed here. And the modern data stack is if your collection of data tools is in the cloud. There are a lot of other things to say here. People have different attributes that they look at, but there seems to be general consensus that your data stack is modern if it's comprised of cloud-based tooling and infrastructure. And that might seem like a sort of simple transition. So what is so good about the modern data stack? I think it's good because cloud-based tooling and infrastructure is, in general, more powerful and less expensive than their alternatives. So this means that folks can buy solutions to hard, common infrastructure problems, and this has allowed a whole new generation of data products and companies to exist that wouldn't have otherwise. So this is a trend that started with the cloud databases in the early 2000s, and we've seen more and more data tools and data infrastructure tools go this way since. And there's a lot to say here, and there's mostly a lot that has already been said here. So I would actually like to focus on something else in this talk, which is that the modern data stack more or less exposes a SQL interface to its users. And I think that this is more than a nice to have. I actually want to take time to detour here to talk about the fact that interfaces are important. So interfaces are important when you're building a product. You want to choose how your user will interact with your product. And you want to choose something that will let your user try it out easily, love it, and use your tool forever. Interfaces are perhaps more important when you're choosing a product, because you want to choose something that will be easy for the rest of your team to use, easy for the rest of your team to understand. So if you wanted to use 5 data products, and they all had 5 different interfaces, how would you convince your team to do that? How would you maintain that? How would you explain that to everyone else in your organization? It gets pretty hard. So having a unified interface can be really important for choosing tools, adding tools to your stack, and making it maintainable. And I wanted to talk a little bit about the power of interfaces by thinking about a ledger. So this is a photo of an old French ledger from Etsy. It's $4 if you're interested. It's from 1906. And the important thing here is not that this person had incredibly neat penmanship, although that is pretty impressive. The important thing to me here is that folks were doing calculations in a sheet-based, cell-based way back in 1906. They were doing this before, but this is the picture I found. Fast forward to the late 70s and early 1980s, and you get a burst of visible calculators. So this started with a product called VisiCalc, which was followed up by Multiplan, which was the original name for Excel back in the day. And folks were so excited about these products that they wrote in the early 1980s that VisiCalc was the first program that was responsible for the sale of entire personal computing systems, at the time the Apple II. And so they didn't need to reinvent the wheel to create a really powerful product here. If you squint really hard, the ledger doesn't look too different from this Excel workbook. They're providing users with a familiar interface and supercharging what was powering them. This holds if you take a step further away from software. So on one side, we have Henry Ford's Model T from 1908, and on the other side, we have the Cybertruck from 2019. These cars, obviously very different, but the user interface is the same. So steering wheel, pedal that makes the car go, pedal that makes the car stop. If you could pluck someone from 1908 who could drive and put them into the Cybertruck today, they would probably be able to make it go, even if they were confused about the cracked window. Why am I talking so much about interfaces? Doesn't really match the title of this talk. My point here is that I don't think that the SQL interface of the modern data stack is just a nice to have. I think it's actually been a key to the modern data stack's success so far. But I think it's also caused one of the biggest problems. And the problem is that the modern data stack has been batch-based because streaming systems have yet to expose that same SQL interface that the rest of the tools are exposing to their users. And I think this has led folks to agree that batch is good enough. So I work at a streaming database company. I talk to users and folks in the community, and pretty often I hear some version of batch is good enough. And I get it. There's so much tooling around batch. There's so much that's already working around batch. Why would you want to change? I have this tweet from Pedram, who's here in the first row. He's at High Touch. And he wrote recently that streams seem to me like one of those beautiful in principle and awful in practice things because of how hard it is to get right. I just can't imagine a 30 to 50 person company with 1 or 2 data hires running off of streams, but it's really easy to do with tables. But the truth is, you would be able to do this if you had a streaming system that exposed the correct interface to its users, SQL. So, say hello to Materialize, the streaming database for the modern data stack, because it exposes the correct interface to interplay with the rest of your tools and with the folks at your organizations, SQL. So for the most part, Materialize acts like the databases you already know and love. You ingest some data, you create views over that data, you power your apps and analytics off of that data. But under the hood, Materialize is implementing that interface very differently. So Materialize subscribes to upstream data sources, including Kafka, Postgres, S3, Kinesis, PubHub, and local files, and we turn those things into queryable streams for our users just using SQL. And our secret is that under the hood, our database is powered by timely and differential data flow. So timely and differential data flow are award-winning, battle-tested stream processing frameworks that came out of Microsoft Research and were co-led by our co-founder and current chief scientist, Frank McSherry. So when you create Materialized views in Materialize, you're actually creating these data flows. So let's walk through, just at a high level, what these different systems do. So timely data flow is a low-latency, cyclic data flow computational model introduced in the paper NIAD, a timely data flow system. And differential data flow is a computational framework built on top of timely data flow, intended for efficiently performing computations on large amounts of data and maintaining that computation as the data change. Okay, do you all got it? Because I'm going to quiz you. That's a joke. The problem here is that this is really hard. So these are actually almost literally the first sentences in each of these projects' documentation. And I know that when I joined Materialize in 2019, I thought I had made a horrible, terrible, horrible mistake, because this is really intimidating. But the good news is that for you as a user of Materialize, you don't need to spend weeks reading Rust documentation or suffering with borrow checker errors to use the power of timely and differential data flow, because we expose this power over SQL. So you can build correct real-time applications in analytics just using SQL and Materialize. And so how this actually is working under the hood at a level that is more approachable and understandable for folks who don't want to spend weeks, months, or years understanding differential data flow systems is that Materialize's superpower is our incrementally maintained Materialized views. To understand them, let's do a quick overview of a traditional Materialized view first. So a traditional Materialized view is a database object that stores the result of a query. And you might be wondering why you'd want to do that, and the answer is cost. Because each time you query your database, you're paying some cost. So that's wall clock time, CPU time, the opportunity cost of not running a different query, and cache. And so what these Materialized views will do for you is cache the results of your common queries. It stashes them in a database object, so instead of running that huge select query that costs you a bunch of money, you run a select query against that database object, which is relatively cheap. So you're effectively caching your answers and keeping them fresh enough. And that sounds great, but it comes with a catch. And that catch is that just like any other cache, Materialized views will become stale. As the data underlying that view changes, the result of that view changes. So it means that if you're selecting from a Materialized view, you're going to be reading stale, out-of-date data, and to update that, you're going to have to perform the same expensive query as before. So using traditional Materialized views, you face a trade-off between cost and freshness. Incrementally maintained Materialized views are the same in one way. They're also a database object that stores the result of a query, but everything else is different. So the result of an incrementally maintained Materialized view changes as the underlying data changes. So they will update their results each time a new row arrives. And this means that when you read from an incrementally maintained Materialized view, you will always get correct, up-to-date results, no refreshes needed. And this might sound too good to be true, so let's take a look at how they work. And I think an intuitive way to understand how they work brings us back to our friend, the ledger. So let's imagine that we're back in 1906. We're running a shop in France. Incrementally maintained views work today, but this is more fun. And now, before we've been dropped into this scenario, the shop has had 3 sales. So one to Jean, one to Marie, and one to Pierre. And these folks were really big spenders. So we have a total revenue of 16 francs. Okay, so imagine Louise comes in and makes a purchase for 3 francs. How would you personally, if you were maintaining this value, calculate the new updated sum? Okay, I'm gonna need audience participation here. If you were going to calculate this sum, would you add 4 plus 7 plus 5 plus 3? Raise your hand. We got 1. We got 2. I feel like an auction person. Okay, would you add 16 plus 3? That's really good for my next slide. Yeah. Okay, so personally, I wouldn't want to recalculate all of the values that I'd already seen. I would look at the fact that I've already made 16 francs and just add 3 to that. Why redo work that I've already done? Instead, we'd want to use the arrival of new data, Louise's purchase, to tell us to calculate the new sum incrementally. So instead of adding up each cell again, we would only do the minimal work required. So 16 plus 3. And I'm really glad you all raised your hands, or most of you raised your hands for the second one, because this is actually exactly how incrementally maintained Materialized views work. So whether your query is simple, like a sum, or whether your query is over 10 streams with 30 joins, with different aggregations and limits and order bys, Materialize will only do work as data changes under your Materialized view, which means that you will get up-to-date, fresh results, and you are not redoing any of your previous work. So now that you know about Materialize's superpower, I hope you're wondering what you can do with it. So as I mentioned, Materialize can ingest data from a variety of data sources, so Kafka, Kinesis, Postgres, PubNub. Some of these might seem obvious, so Kafka and Kinesis, those are data streams. Makes sense that you can query those as a stream. Some of these tend to trip folks up, like Postgres. So the way that Postgres works with Materialize is that we subscribe to their wall log of their tables. So you tell us what table to track, we subscribe to that table, read the wall log, and we're basically doing change data capture for you. So as you add to tables, as you update the values in your tables, as you delete rows, you can interact with that as a queryable stream in Materialize. So you don't have to set up CDC yourself, which is a pretty big win, actually, for most folks. So what you would do here is you would create a source in Materialize. So these are all data sources. You create them with a create source SQL statement. And once Materialize is subscribed to your upstream data sources, you can create your incrementally maintained Materialize views using a create Materialize view statement. So Materialize is Postgres wire compatible, so it looks just like the create Materialize view statements that you've used in Postgres. Okay, so I have a demo. Let's see if it plays. It does. Okay, so this is me in my shell the other day. I'm going to be connecting to a Materialize cloud instance. And here we are talking to Materialize. So I'm going to create a source from PubNub. So PubNub is a service. They also provide some free streams of data. This is their market order data. So it has ticker symbols, and then it has fake stock prices flowing through. So I'm creating a source from an upstream data source. And it's coming in as just a blob of text. So I'm going to use a view to cast the fields in that blob of text into things that we actually want to use. So like bid price as float, order quantity. And then you can see that I've created that view, just a normal view. And from here, we want to create our incrementally maintained Materialized view. So what we're going to do in this demo is create one that calculates the average bid price for each ticker stock symbol. And so the statement here looks like probably anything you've executed in Postgres or other databases. And this is transforming streaming data in real time. It's actually doing this already. I wanted to show off the columns. So as the data is changing, you can see that the average bid value for each symbol is changing. And you notice that we aren't refreshing these Materialized views. We're not prompting it to recalculate anything. As Materialize is ingesting new rows of data, it is doing the work for you on push. This is just a watch command that's running that same select in a loop. Ta-da. This is Materialize. Thank you. So this is how Materialize works. This is our superpower. As I mentioned, this is also a simple example. We work for joining streams across systems, for 30-way joins, for lots of data, but this kind of gives you an idea of what a Materialized view looks like. Okay, so once you've transformed your streaming data, you might be wondering, what can I do with it? So you can query it interactively via pSQL, via SQL, via any of your SQL tools. So as I mentioned, Materialize is Postgres wire compatible, so we play well with the Postgres ecosystem. Actually, if you ever find that we don't work well in the Postgres ecosystem, please open a GitHub issue because we very much respond to those. Other ways that you can work with Materialize is to power real-time BI and analytics. So we work with Metabase, we work with Hex. You can make real-time visualizations with Materialize in those tools. And then another one is real-time applications. So we actually have someone in the audience today who is using Materialize for real-time applications. Hi, Emily. That's Emily. She works at Drizzly. She is a Materialize user, and she is using Materialize to power their real-time abandoned cart emails. So for those of you who aren't familiar, Drizzly is an alcohol delivery service, and they found that folks who put tequila in their cart today don't really want to buy it tomorrow at 10 a.m. So pretty compelling. So they're using Materialize. They have a data infrastructure that goes Kafka, Materialize, Kafka, and they send out their abandoned cart emails within 30 minutes. So that was a big deal for them, and it was fun for us as well. But there are lots of things that you can do with Materialize. We have IoT use cases, finance use cases, e-commerce use cases, and there's lots to talk about there. I would encourage you to come by our booth or my office hours or our community Slack to get ideas about what you can build with Materialize. Because for the rest of this talk, I want to talk a little bit more about how you can build with Materialize. And my answer there is using Materialize+dbt. So you could pretty easily create sources and materialize views and push data out to external systems, all by handwriting some SQL queries. But there's often a better way to do that, and that's with dbt. So if you're familiar with dbt, you probably know that until recently, dbt only transformed batch data in batches. So you might be wondering, what is different with streaming data, and how does that actually work in real time? The good news is that almost everything is the same. So if you're using dbt, particularly with a Postgres database, you could probably point it at Materialize, and it will just work, because we're Postgres wire compatible, which I'm probably going to say 5 more times. So the model definitions are exactly the same. Materialize speaks SQL, so you just put your SQL in there. You get to use the same dbt commands, so dbt run, dbt docs, dbt test. I put an asterisk there because they behave a little bit differently, but I actually think y'all will be pleasantly surprised. And you get the documentation and lineage that you are used to, which is great. That surprises some folks that you get the same thing over streams, but we're just SQL, so it all still works. So what's different? To create the incrementally maintained Materialized view in Materialize, which is just our Materialized view, you just need to use our custom Materialized view materialization. It's tough to say that so many times in a row. But that will create the Materialized view that we just saw in the demo. That will auto-update. You never need to update it yourself. And then how some of the dbt commands are used is a little bit different. And this next one is my favorite slide, especially if y'all are using dbt, so hope. You get to dbt run your models once and never again. I'm clapping for myself. I think this is really exciting. And this works because if you're creating an incrementally maintained Materialized view, we are doing the work for you. So this is the whole point. Like, you don't need to refresh your Materialized views anymore. You don't need to push. You don't need to schedule. You don't need to check your alerts. You don't need to make this perfect little schedule to make sure everything gets transformed in time. You just dbt run your models once and never again. I wanted to show that off, so I have another demo. Okay, so this is building the same thing, but with dbt. So we're back in my shell. dbt projects look the exact same because it's just SQL. So we have some models. So that's our source. That's our view. And here's our incrementally maintained Materialized view. So you see the materialization type is our custom type. And other than that, this is just SQL. Nothing fancy, nothing special. You don't need to know anything about streams, just SQL. So that's the same SQL that we executed before. And you can see that we're connected to my cloud instance. I deleted this after, just so if anyone's worried that I shared. And perfect, and we can dbt run our models. So we have our source, our view, and at the bottom we have our analytics.averageBid. So that's the same thing that we created by hand, but we created with dbt here. And here's the same watch command that's selecting from that Materialized view. Ta-da! It did it again. It does it every time. So this is the same thing, but using dbt and Materialized together. So this is a smaller project. You might think it's kind of simple, but it gets handy when you have a lot more views. And then dbt docs also works. So docs generate, docs serve. I probably shouldn't have clicked allow here, but I was stressed. So, So this is the same docs website that you see with batch data, but with streaming data. And here's our average bid. I apologize to DBT folks for not documenting this, but same SQL and same lineage graph. So you can get lineage graphs over your streaming data, works just the same because Materialize speaks SQL. And dbt test works on streaming data too. So you can run dbt test on your Materialized views to actually catch data quality issues in real time. This is super fun. So this is an idea that came from Josh Wills. So quick shout out to Josh Wills. He actually created the first version of the dbt Materialized adapter. So this is all from him. Thank you, Josh. But he came to our hack day a few weeks ago that we held in collaboration with Red Panda and with dbt. And his project was, can I find issues in my data faster with Materialize and dbt? So he built this working project. We actually have a GitHub repo of a bunch of Hack Day working projects that if people are interested, I will share later. This is just a cool one. And so he would purposefully inject bad data into his streams to see how quickly he could catch it. And he was running this off a 15-minute cron job and caught everything because it's just SQL. So it was just a SQL statement looking for issues in the stream, and he caught it. He realized after this that you could actually run this off a tail of Materialize. So tail is just like a Unix tail. It's just a stream of the changes. So you could actually catch these in real time and like divert them from their downstream destinations if you catch an issue. So that probably should be my next talk. So stay tuned. So we're back to Pedram. I just had to highlight him a few times. And I said earlier that folks have decided that batch is largely good enough because streaming systems haven't really exposed the correct interface to fit into the rest of the modern data stack yet. And that's why I'm personally really excited about Materialize. So I was an early employee. I believed pretty early in the product. I'm excited about how it's going so far. And I feel like the original set of modern data stack tools let a new generation of data products and data companies exist because they could buy instead of wasting their time on common, hard data infrastructure problems. And I see Materialize today as doing the same thing. So Materialize gives the power of cutting-edge, battle-tested stream projects, and it lets people build on top of those just using SQL. So we can bring real-time applications and analytics to every data team, even if that data team only has a single developer or a single analytics engineer, because it's all just SQL. Now, if you're like Pedram and you haven't tried it out yet, I'd encourage you to stop by our booth or my office hours or our community Slack to get your hands on a demo. We have some simple ones available. We have some more complex ones available. And we're more than happy to walk through your personal use cases and see where we might fit. I'm pretty confident that we will live up to the promises that I've made today, and I'm really excited to see what you all do with it. Thank you.